Hello everyone and welcome back to Prince Exam Boost. We are still talking dimension, and this is a final video to help you manipulate questions related to dimensional analysis. We have just about 3 complex examples, after which we are done. But before we continue, I would like us to find the dimension of this important parameter called the universal gravitation constant. If you remember vividly, when you learned gravitational field, we were told, according to Newton's law of gravitation, that the force of attraction is related to the masses using this formula G m1 m2 all over r squared, where the m1 m2 represent masses, the r represents the mean distance between their centers of gravity, and the F means the gravitational force. So here comes the universal gravitation constant, G. So in our bid to work out the dimension of G, we have to first make it the subject of the formula by cross multiplying. This means that G m1 m2 becomes force multiplying r squared. And when you try to make G subject of the formula now, it now becomes force times the square of distance all over m1 m2. So moving on from here, we now have to piece out the dimensions of every single one here. We already know the dimension of force. So dimensionally, force is mass times acceleration. So in bracket, we are going to have mass times acceleration, which is LT minus 2, multiplying radius is distance. So r square will be distance square, all divided by mass, and mass are 2 fundamental quantities, m times m. So if we do this, one of the masses cancels out, leaving us with length raised to power 1 times length raised to power 2 becomes length raised to the power of 3, and then t power of minus 2 all over mass. So dimensionally, it is mass power 1, L power 3, and time raised to the power of negative 2. Or if I'm trying to put the positive first, that becomes L cubed mass power minus 1 and time power of minus 2. So that's the fundamental, that's the dimension of universal gravitation constant, which means if we go for units, length is meters, so this could also be by unit, base unit. This will be meter cube per kilogram per second square. All right, so that is that for the dimension of universal gravitation constant. So now let's talk about a question on dimensional analysis which require the use of this formula. The question says that the period of oscillation of a star may vary with these different parameters, first being the radius of the star, then the density of the star, and lastly the value of gravitation constant. We can now turn the variation into equality, and remember what I said we always do: we introduce a constant, and since we don't know the nature of the variation, we will introduce constants on each of them. So I'll be using A, B, and C. So what do? We now piece out the dimensions of what's on the left. So dimensionally, period is measuring time, so the dimension remains as t. Radius is measuring length, so the dimension will be replaced as L. Density, as we've done many times, mass per unit volume, that's ml raised to the power of minus 3. And lastly, the gravitation constant. If you don't know it, you have to go learn it from the previous video we just did. So gravitation constant has been confirmed to be L raised to the power of 3, m raised to the power of minus 1, and t raised to the power of minus 2. So you know what we do next at this phase. We will now use these dimensions to replace the quantities and raise each dimension to the power that was listed in the question. So this becomes t equals to, well, k is a constant and has no dimension, nothing to worry about. Changing arrow now to L raised to the power of a. Open a bracket. The expression for density is L raised to the power minus 3, so we are raising it to the power of b. And thirdly, for gravitation constant, we open another bracket and we infuse these values: L raised to the power of minus 3, m raised to the power of minus 1, and t raised to the power of minus 2, all raised to this power of c. We neatly open up, being very careful along the way. K becomes L raised to the power of a, m raised to the power of b, L raised to the power of negative b, while on this other bracket, when opening up, L is raised to the power of 3c, m is raised to the power of minus c, and t is raised to the power of minus 2c. We are almost there. As we can see, currently we have different parameters for length, different for mass, different for time. So let's arrange them all using the laws of indices. So L will be, since they are multiplying each other, we will just add the powers. So we have a minus 3b plus 3c. While for the mass, we only have power of b and power of minus c. So b minus c. And for time, we have minus 2c. So we will compare powers on both sides. Wisdom demands that you start with the powers with fewer unknown variables. For example, if you check, the power of time only has minus 2c. If I want to go with mass, mass has b and c. And if you go for length, length has a, b, and c. So wisdom demands I would start by comparing the powers of t. It doesn't matter actually, it just makes things faster and easier for us. So comparing the powers on t now. For t, on the left hand side, the invisible power is 1. So 1 is equal to, on the left, minus 2c. Right away, we can solve c immediately. This means that c is equal to minus 1 over 2. First one has been tackled. We move over to the coefficients, the powers of m. Now for m, looking on the left hand side, you find nothing. So what does that mean? It means 0 will be equal to what is on the right, which is b minus c. Now, if you collect like terms, what does that mean? It means b is equal to c. Oh, let me not confuse you. If I take minus c over, it means c is equal to b. And we have already found c. So what does that mean? That means b is also minus 1 over 2. Second one has been found. And thirdly, we can now go for the powers of L. For the powers of L, there is no length on the left hand side. So that also means that the powers on the right will be equated to 0. So 0 on the left is equal to a, which is unknown, minus 3b plus 3c. Okay, so leaving a on one side, bring the other ones where they belong. So 3b minus 3c is how we get a. So that means that our a becomes 3 into minus 1 over 2, subtracted from 3 into minus 1 over 2. What does this give us? This gives us minus 3 over 2. Minus times minus now becomes plus 3 over 2. So you can see clearly Minus 3 over 2 plus 3 over 2 is going to give us 0. So which means that period of oscillation does not depend on the radius of the star. So this is going to vanish. So we have T equals K R raised to the power of 0, density raised to the power of minus 1 over 2, and gravity raised to the power of minus 1 over 2. What does this mean? To be more decent, this is out, the constant is left. Since they both have negative powers, we will take them to the denominator so their powers could be positive. So this becomes density, which raised to the power of half, and gravitation constant raised to the power of half. And we already know, according to indices, that the power of half also means square root. So this simply means that the period of oscillation is represented by square root of density times the square root of gravitation constant, which when brought together now becomes K divided by the square root of both density and the gravitation constant. So that's an interesting example, don't you think? Practice makes perfect. So even the examples that have been treated, I advise you to rerun each example again and again until you gain mastery of these concepts. And when you see new formulas, it will also be easy. Now let's move on to 2 other examples and we're done. All right, so let's attempt this tricky question. It says that the height a liquid could rise in a tube could depend on the density, could depend on the gravity, and on surface tension. While in the question it was clearly stated that the height varies inversely as the radius of the capillary tube. So what that means is that for the joint variation, when I'm joining them together, this one has already been experimentally proven, and so it's not going to have the unknown variables. Only these ones whose relationship has not fully been determined will have those unknown variables. So joining them together, my H becomes equal to an unknown constant, density with an unknown power, gravity with an unknown power, surface tension with unknown power C, all divided by radius. Now radius need not be given any power because it has been experimentally proven. So what does that mean? It means that our H now becomes the K into density raised to the power of A, gravity raised to the power of B, surface tension raised to the power of C, and radius raised to the power of minus 1. So with that said and done, we've now gotten the straight linear relationship for this evaluation. We know what we should do next. We have to go piece out their dimensions individually. We know that the dimension of height is length, L. The dimension of density has been proven as a mass per unit volume, so M, L minus 3. That of surface tension was proven as mass force per length, which gave us mt to the power of minus 2. And radius is actually a measurement of length. So with this, we can now insert everybody into the original equation. H is replaced with L, and this will be equal to constant with no dimension, replacing the density raised to the power of A, gravity, which we know, gravity was not listed there. We already know the dimension of gravity right from time. Gravity is LT minus 2. It's an old concept, we've used it many times. So we change gravity into the power of B, and we change the surface tension into mt minus 2 raised to the power of C, and then radius is now L raised to the power of minus 1. So you know what we do next? We open up the brackets using the laws of indices. the powers will be multiplying the unit powers of the values in brackets. So m will now be raised to the power of a, l to the power of minus 3a, l will be raised to the power of b, t to the power of minus 2b, m to the power of c, and t to the power of minus 2c, and lastly l to the power of minus 1. So we now use indices again. All the ones with the same base, we are going to add their powers for respecting the signs that they have. So I'll start with m. If I go with m, there is a here. The next value is plus c. Then we move over to l. There are 3 parameters with l. We have 1, 2, and 3. So that's minus 3a plus b minus 1. And then lastly, these are all the powers on l. And then lastly, for t, we have minus 2b and minus 2c. So minus 2b minus 2c. Okay, now that we've done this, you know what we do next? We compare the powers. Unlike the other examples we've also done, so there are always at least 2 variables, so there is no way we can escape. We just have to pick anyone we want to start with. So let's start with the coefficients of L. On the left hand side, we have an invisible power of 1. It must be equal to the power of on L here, which is minus 3a plus b minus 1. So let's just make it look standardized. If minus 1 was to move over, it becomes plus 1. So total is that 2 equals minus 3a plus b. So this becomes our equation number 1. Next, we move to the power on m. On the left hand side, we don't have any m, so that means 0 will be equal to what we have on the right, a plus c, right? A plus c. This becomes our equation number 2. In advance, let's immediately make a subject of the formula here. So a is equal to minus c. Please, let's take note. You are going to know why soonest. And lastly, the powers on t. So for the t, there is no t on the left, so that means 0 will be equal to the powers we have on the right. For t is minus 2b minus 2c. So this is our third equation. What do you do at this stage? Here you had a and b, now a and c, and then b and c. All you just have to do, make one subject of the formula in one of the equations, like I just did in equation 2. I made a subject of the formula to get minus c. Now take this value of a and insert it in the next equation that had a in it. So what I'm going to do is substitute equation 2 into equation 1. So what does that give us? Our 2 would then be equal to minus 3. Instead of writing a, I open my bracket and I put my minus c and then plus b. So what does this give us? 2 is equal to 3c plus b. Now what have we just done? We have gotten an equation, this one, which is equation number 4. We have gotten an equation that has the same variables as the third one. So the third one was minus, let me write the c before the b, okay, minus 2c minus 2b. So this is very important because now we can solve it simultaneously. You see, we can solve these two as a simultaneous equation. So I would like to use the usual. I would like to use elimination method so I can easily arrive at the value of b and c. So what do I do now? I want to eliminate c. So this has minus 2. I'll multiply the first with minus 2. While they have 3, so I'll multiply the lower one by 3. Place by multiplying it by minus 2 and then multiplying this other down part by 3. Minus 2. I get minus 4 equals minus 6c minus 2b. Why? When the lower part is multiplied by 3, I still have 0 here equals, I have minus 6c, and I have minus 6b. So at this stage, we subtract both equations in order to eliminate the c. So minus 4 minus 0 is still going to be minus 4. Minus 6 minus 6. It's now going to be minus 6 plus 6. So that's giving us 0. So c is out. And then minus 2 minus 6. That becomes minus 2 plus 6. So that's giving us 4b. So what that means is that 4b is equal to minus 4, meaning that b becomes what? Minus 4 over 4, which is minus 1. So if we have the value of b now, we can quickly insert it anywhere to get c, right? So I would like to insert it here. So sub into 3. Since 0 was equal to minus 2c minus 2 open bracket, the b has been confirmed to be minus 1. So what does this give us? Minus 2 times minus 1 is plus 2. So 0 equals minus 2c plus 2. With this moving over, minus 2 becomes equal to minus 2c. If you now divide both sides by minus 2, your c becomes equal to 1. Second value obtained. And lastly, we can take it to where we saw c, which is here, a, because we already have b and c. So putting it here, our a becomes equal to negative c, which means that our a will be minus into the value of c is 1. So a is equal to minus 1. That means the original equation we had, which said height equals the constant, the density, the gravity, the surface tension, and then the r raised to power minus 1. What we had as their powers were a, b, and c. Okay, so this becomes h equals k. What was the value of a? A was minus 1. B, which is for gravity, it's also minus 1. And then c, which is for surface tension, was plus 1, and then r is minus 1. So what does that mean? All the ones with negative powers belong to the denominator. So our h is truly, we'll leave the ones positive above, so we have k and this, while at the denominator we have density and gravity. So this now and radius, and radius. So this now becomes the relationship of the density, surface tension, gravity, and radius with respect to the height it rises in the tube.